Hello again. The last video I mentioned that when developing these high-speed machines, the normal debugging method had almost fallen apart. Some people might think that's nonsense. Well, this time I will try to explain why a high-speed camera is needed when debugging this. First, let's see what happens when we turn the cube at low speed. As you can see, the cube follows wherever the centerpiece goes. Exactly what we expected. Alright then, let's see what happens when we turn the centerpiece really fast. It's done. Did you realize what just happened? Maybe not that easy to see. This time, I put a sticker at the center as a reference and watch carefully. I think you can tell that the centerpiece turns 90 degrees every time, but all the pieces didn't turn at all. Wondering why, don't you? Okay, this time, let's watch it again, but let's put slow motion. Oh right, that's what happened. The centerpiece was turning really fast that the other pieces didn't even have time to respond because of the inertia. When this situation happens, the curve of the debugging system seems alright. Nothing goes wrong when we only read the data on the screen. So next question is, why that happens? Many people might have the experience of buying a low-quality Rubik's Cube, which is really hard to turn. Every time it has to be perfectly aligned so that the other face can be moved, and that's bad for high-speed solving. So when we try to solve a cube at high speed, the misalignment is not avoidable. A cube which is designed for high speed solving makes the misalignment turns much easier. It can correct almost 45 degrees of misalignment. Unfortunately, this is the source of our problem. When we lose the screws, we get a good error correction feature, but also lose the control of the cube. If we tighten the screws, we could turn the cube quite well, but lose the error correction feature. And the worst thing is, it will introduce more friction, makes it a lot harder to turn. So, is there a way to turn the cube but with less friction introduced? Well, of course, and that's why a high-speed camera kicks in. Okay, here it comes. Do not screw too tight or too loose, just the right amount of force in between. Sounds easy, right? As it turns out, not quite. The quest for finding the right amount of force is quite painful, actually. You can watch this demo. With this setting, we are able to turn the cube and very few friction introduced, which is great. However, if I slow it down 20 times for you, and you will realize the problem. The centerpiece has arrived at the target long before the cube was settled. We actually need to wait for the wobbling of the outer pieces until they were settled. But in this stage, the program thought that the move was done and ready to turn the next phase, which is wrong, obviously. The process was tighten a little bit or lose a little bit the screws of each face to see which gave both the minimum wobbling time and minimum friction, and this is part 1 of the job. The other part of the job was much more interesting. You see, braking with full reverse power when we reach the target position, the outer pieces always go beyond then come back, and that costs quite a lot of time, which is not supposed to in the first place. But soon it occurs to me that I could use this phenomenon to save some time. How so? That's why I said part 2 is interesting. Imagine this. If the target is 19 degrees, the outer pieces always go beyond 110 until the velocity reaches 0, then bounce back. It means the furthest braking distance is about 20 degrees away, hypothetically. Why don't we try to brake when it reaches 70 degrees? And when it decelerates to a complete stop, we cut the reverse braking power. Then the outer pieces will stay where they are, which is very close to the target position, about 19 degrees. In this way, the actual moving time is less than before. Well, of course, the reality is cruel. Different voltage of the battery, different friction of each phase, and different velocity at different braking position could end up pretty far from what I expected. That's why we need a high-speed camera to watch what happened exactly every time and tune the parameters step by step. Most of the tuning job is setting the camera, recording the movement, taking out the SD card to the computer and watching the video frame by frame. Then adjust the parameter and repeat the whole thing again. Alright, I guess you got the idea now. It's an exhausting job, yet still, it's pretty cool. If you like this video, please give me a thumbs up. If you want to know more about this project, please subscribe to my channel and check out the previous video. Have a nice day. See you next time.